covering optimization concepts and methodologies last week. And this week, because to get you prepared with the individual projects, you need to start to get prepared to use the software to really solve the problem. So we moved this computer training session earlier to the third lecture this year. So you will be able to learn the different software tools. Especially today, the 3 TAs will help you go through the different methods of Matlab, GAMS, and Python to get you prepared to start working on your projects. Okay, so I have updated the individual project requirement on IVLE already. You go to the IVLE folders, you can find the project requirement. So if you have a problem in mind, you can start to communicate with us about the topic to see if it's useful or not. So I put something here. So before we go through the official training session, I put this website right here. It's like real-time Q&A. So I hope you can use this because I will be sitting there to learn with you. So I will answer your question real time. Our TAs, our guest lecturers later came to give us an overview. So anything about you can keep the website down, or if you have a computer, you can write it down. To use this, you can find this Q&A session, and I will answer your question there real time. And also, the second tab is a poll, POLL, there. You see the symbol there. The poll is to get some basic information from you as well. So I will later on activate the poll so you can give us some feedback about the software and the class. We just open the slide though, and W022 is the room number, so you can enter the chat room to start working with us. Okay. Remember this. You have your laptop or your phone, you can connect to our web link through here. So anything you want to talk with your TA or with your lecturer, you can also put your question there. I'll just answer that tonight. Okay, so let's first have, so it's the software session. Let's first have the TA to give us an overview. But let me start to introduce you briefly this page, and later on when we go to the Matlab session later. So this gives an overview of the optimization software. You see it's allowed because optimization, in the old days, you can do it by hand to solve some small-scale problem. If you do industry scheduling, you want to have 3 products, you can calculate by hand, do the integration. But now all those softwares can give you very good functions. So I really want to get to know which one you have used before and which one you prefer to use later. But in this class, today we show you Matlab. So later on we should see Matlab has been actually used in your previous learning, so it has a lot of nice functions. So we'll use some functions as well. Also it has a toolbox. So toolbox is very convenient now to get you, everyone can use it nowadays. And the GAMS is also listed here. We commonly use it to solve the large-scale optimization modeling problem because it's really for the general algebraic modeling system. Also, Python can do a lot of solvers, but the other are all very good. Some are open source, some are even very nice free user face. Like the AIMS, first one is open, it's free for education users. So for apply for educator license, for student license, you'll be able to use the modeling platform, and it has a lot of solvers, and the realization is also very nice. And if you are good with programming, you can then use some of the Ruby or Simplex. So these solvers, this website can give you very good information about how to solve our complex problems. Okay, but now we focus on the Matlab first. And then the 3 TAs will talk through Matlab, GAMS, and Python. So it's a quite hands-on session. I fully encourage you to follow those steps. Or later on, if you want to try some examples. But next week's screen is a Chinese New Year, right? So we have the next week no class. But I hope you can use the time to start working on your projects already. But the week after next week is February the 12th. We will have the computer-based session. We won't have the class in this room. I will send the announcement to them, but in 2 weeks, we will have the class in the E5 computer room. So we will meet there and then go through the code again and work on some more advanced hands-on examples to reinforce what you learned today in this classroom. Okay? And then also after the training, the computer session, we will have the quiz there. So it's a computer-based quiz. Some students asked me already, so I will have multi-choice examples and some of that. I will give you some sample questions later on, but the quiz is after the class in the computer room. Okay, so what we learned by them will also be covered in the quiz. Right, let's start with Matlab. So the TA Jiali Li will first introduce it. To you.
Hi. Hello everyone, I'm Jiali, and I will introduce you about Matlab, which all of you may already be familiar with. And this is an interface of Matlabs. You can see it's quite easy to use. It's like the Word documents or something like that. You can open a file and you can edit it. You can create the functions you would like to create, and then you can write scripts to use the functions and use all the to make use some packages built inside Matlabs and directly to solve your questions. So Matlab is quite easy to use. And every year it will have more and more functions and more versions. So please keep in mind you keep update of all the things in your mind, and you can read all this from the Matlab community, and that is quite easy to access from your web, and you can just Google it. And actually, the Matlab I think is the easiest software to use compared to GAMS or Python, because firstly, the interface is quite good. But I recommend you don't use Matlab as your lifelong software because it costs a lot. If you go to companies or other places, most of the company will not give you Matlab to use. So it's better in the Python section you listen to more, because Python is free and open sources. And first I will talk about some of the searching algorithm of optimization. This is a Simplex search algorithm. It is you first find an initial point of 1, and then you try to search two different points, the point 2 and 3, and then you try to map this triangle to another from the side to another point. You find the point 4. This is how the software do this to approach for the minimum value of a function. This is not a difficult function. This is just 2D, and you can see you can have more difficult searching methods like the conjugate search methods, which can have some modification of the Simplex algorithm. And the thing is, never try to write down the codes for Simplex method or all this kind of algorithm unless you are quite interested in the mathematics of it. All the things are already well built inside Matlab. You can just use a simple or one-line command like fmin search. I use it for my individual project last year, and this is quite easy to use. And fmin search is not the first important thing is you have the function. You need to define your function first. If you have a project of a reactor design, then you need to firstly model the reactor. You know the reaction kinetics of the reactions inside the reactors, and you know the mass transfer and heat transfer inside. Then if you want to optimize some of it, then you need to find the function, the optimization object function of it. That is the most important step. After you have find your objective functions, then you write the function inside Matlab with the function code, and then you can just maybe you name it as function 1. Then you just write function 1 here. Then the fmin search will know you are trying to find the optimal point for function 1. And then you choose the initial point, which is x0. And sometimes to find the initial point is quite tricky. some of the industrial engineers, they solve the question because they have an experience. They know about 0.8, and they want to find the optimization point of it. But they know it's around 0.8 or something like that. Then that is easier for you to search. If your answer is 0.9 or something, and you write the initial point as 10,000, it may have some problems of it. So to find the initial point, you need to understand your objective function quite well, and to understand the problem you are going to solve quite well. And also, it's like there are different forms of how to use all this kind of functions, like the command, like fmin search. You can just use help button on your Matlab, or you Google it online. Then you can know how to write it differently. But mainly it has similar functions. You just can write it in different ways. And for this part is like you can know more, because they build this kind of packages quite well inside Matlab. And you can get more information rather than just the optimal point. They can give you how many times it has been calculated to approach for the optimization point, and how long it takes. So this thing is some optional that you can write down to know what kind of information you can look out of your functions. And all of these are written in the Matlab community, so you can read the documents once you want to use it. Fmin search is quite easy to use function, so many problems can be solved by this. The constrained or unconstrained problems, it can also have different ways to solve it. And this is an example. It's like you first define the functions, and this part is to define the function and to draw it with the command here. Firstly, you need to define the function. The object function is this one, f2. And this has two independent variables. And then you can use linspace and counter command to draw it. And then you can see how it looks like. And if you want to find the optimum point, you can. Maybe after you draw it, you can find it by yourself. But actually, you can just write down the functions and then use the simplex method, like some fmin search, and then just add this function here, and then it's gonna give it an initial point, and to find which is the optimum point of it. It will give you the results directly. Quite easy to use. And this one is for all this Matlab scripts you can find on Emily actually. And for this one is another example of a two-variable, which is two-variable functions, and you have independent variables x and y, and then you can still use fmin search, and you can see this one. The options is to see how long it takes, and you can know all the information, the exit flag and output, and what's your tolerance, and so on. All this kind of information. You can just use one line of command to get all them out. And after the simplex search method, there is some built-in gradient-based search method as well. Gradient-based search method is first you choose an initial point, and then you try to know the search direction of it. The search direction is usually to minimize along the direction to find a new point. And I think Dr. Xiaona will talk more about this kind of technology in your future lectures, because this software lecture is moved forward. And normally, the most important thing is you need to find a great initial point. And you can try to search it, or you can try different initial point. Just you can have a space, maybe 0, 10, 100 to search which one is the best initial point you want to use. And then you need to have a criteria, it's a tolerance. How different is the final two results? If they are very close to each other, then the code will stop and tell you that is the optimum point for this kind of software. This is a mathematical form of gradient-based search. You can see if you have very complex functions, more than 1D or 2D or 3D, then you need to write down the secondary derivatives and the Hessian's matrix of it to calculate for what you want. And sometimes you have many variables. It is quite difficult to do by hand, so the software can take care of all these problems. This is the oldest method of gradient-based search. It's a steepest descent. And it's try to find another method is Newton's method. The only difference between these two is you see there is a second derivative terms for Newton's method, and the search direction may be a bit different. But when you use a software, it will just lead to the final answer you want. And for Matlab gradient search method, you use this command, the fmin unconstrained, is to solve the unconstrained problems. Normally I use fmin search because fmin search can solve for constraint problems as well. And if for your individual projects, normally you will have some constraints. Because for unconstrained problems, it's not really realistic, and it's not that meaningful to do this kind of problem solving. And this is one of an example of how to use optimization for data fitting. Actually, all the data fitting problems is done by some optimization ways, because you are trying to find the hypothesis, which is a function itself, by giving the data, giving the training example to it. You have different training examples, and then you try to have a loss function. For here, it's quite simple. It's to minimize the difference between y and the. It's a square error of the standard square error of the function of the whole functions, and you can see that. Firstly, you will to identify. You will have a hypothesis of what function, the real function, the hypothesis you want, the function you think that works. And then you have some parameters that you are going to find. The parameter here is a lambda. And it will search for what is the best value for lambda, that the real data, the y value of the data, and the error between the estimate y value from the hypothesis, the function you have, and then this is your objective function. So the most important thing of solving an optimization problem sometimes is find the objective functions. If you find it, there are a lot of dozens of software for you to use to do the optimization tasks. And it's quite important for your individual project. It's like you have a very complex or quite well-defined problems, and then you try to identify all the objective functions and the constraints you have. Then you put all of them, write down all of them in the form of the function you want for different softwares. GAMs have different ways. Then you will introduce you that. And for Matlab, you just write down all these kind of things, and then you just one line command. You can get the results you want. And I will pass to Lan Yu about the GAMS part.
Thank you, Jiali. In today's tutorial, I'm going to talk about how to use GAMS, and it is a very useful optimization software. I will guide you one step by step to achieve a goal, to write a code, and then you can solve the question yourself. So, GAMS is it's called General Algebraic Modeling System. It is a modeling language for linear, nonlinear, and integer optimization problems. It is specifically designed for large complex problems. And there are a lot of solvers inside the optimization software so that you can write down the formulation of the problem, and then you can choose whatever solver that is suitable for the problem. So it is very convenient, and the main syntax framework of GAMS includes several parts, which are sets, parameters, variables, equations, and models. So let's get started. This is an overview of the solvers in GAMS. There are linear programming problem solvers, nonlinear programming problem solver, and global solvers. In GAMS, you can open a window like this, so that the solver with a tick. This column means the names of the solvers, and these are the types of the problems, like linear programming, mixed integer programming, nonlinear programming, etc. So when it's suitable, there will be a tick there. As we mentioned just now, the structure of a GAMS model includes the inputs, which are set declaration, data input, variable declaration, assignment of the bounds of the variables, which is optional, and the equation and model and solve statement. Finally, you can display your results using the display statement. Before we start, I would like to talk about the installation. Have you installed GAMS in your computer? Yes, great. And if you have installed the demo version, there is something you need to know, that the number of constraints and variables allowed to be solved is 300, and the non-zero element is 2000. And so this is the constraint of the demo version. So when you write your code, please take note. Otherwise, after you finish coding, you'll find that demo version is not able to solve this problem. But if you cannot solve it, there is another software. There's another online website that you can solve nonlinear problems and complex problems. I will show you later. Let's start with the syntax of the GAMS model. Before we write down the equations, we need to define the sets, which is the category like this. For example, here I means canning plants, which include a category of Seattle, San Diego, and you can also add other places, etc. And we define another set as markets, which is New York, Chicago, Topeka, etc. So sets means when you define a variable, you can when xi is defined, xi can be x1, x2, x3, etc. So I is 1, 2, 3 here. And after three ways of defining the set. The first one is defining like this, and you can also use the star. When a star is used, it means from 1991 to 2000. So 1991, 1992, 1993 to 2000. So this way, which is demonstrated here. So this way is more easy, more convenient for you to define new sets. When a set is defined, you can also use this to make these two sets exactly the same. So this three lines of code, when you put into games, it will appear like this. So there is color coding in games. This one is sets. So you must write this one in games. And then ij is what you define as a symbol. This is the description of the symbols. So these two lines is optional. You can either have it inside or not. And this, you must have the slash and include all the categories inside all the sets inside the same the category.
Sorry.
Okay.
What's the difference between set and sets?
Same. It's the same.
So I can write sets
Yeah.
for the second one also.
Yeah. Great. Please feel free to ask me any question because I may miss some important information. And to define after defining the set, we need to input the data into the code. There are 4 different types of methods to input data. The first one is data entry using parameters. You write parameters and then define your symbol and description, which is optional, and put the set and value inside. So this is the first way of defining the parameter. The second way is data entry using tables, like this table, and then put your symbol and description, and then put it as a table, so that these two are the two indexes, and these are the values that is input into games. The first way is using data entry by scalar. So you can define a scalar f, which is 19. The fourth one is data entry using direct assignment. So after, for example, after defining Bij and f, you can calculate a new parameter Cij using f, which is a scalar, times this table to get a new parameter. Then this is the syntax of variable definition. There are several variable types, which are free variable, default, positive, negative, binary, and integer variables. So when you define variables, you put variables and then put your symbol definition here, and as well as the statement about this symbol here. If you need to define positive variables, you just put positive variables, and others can be also defined in a similar way. When you define variables, you can also assign the bounds of the variables. For example, this line means that the upper bound of variable f is this parameter, and the lower bound of variable f is 10. The upper bound of this variable, which one calls the exact value in this variable, and it should be equal to this one. For example, this one, capacity Seattle, New York, is here. For example, if this is capacity, so capacity Seattle, New York should be this value. So it means that the corresponding one in the variable should be 1.2 times the one in the parameter table. Is it clear? Yes, okay. Then we can define the equations. Equations definition consists of two parts. First, you put a name to describe this equation. For example, we put cost to define the objective function. Then you write down the exact equation of the cost using the variables and parameters. Then you can calculate. In the equations, L means less than, G means greater than, and E means equal to. So you cannot directly use equal to in the equations. You must use equal, E, and equal in the equations. But when you define a parameter, you can directly use the equal sign. In games, the sum of xij, sum of all the j elements, it can be written like this. And this is the sum of Cij times Xij. So you need to put what you want to sum up here. So here we only sum all the j items. For example, this is equal to xi1 plus xi2 plus xi3, all the elements. And this one means summing up all. Okay. This is the product of Xij. After the definition of sets, parameters, variables, and equations, we can set up the overall model and solve the problem. In this page, this model statement means you can define whatever name you want. This line means model the transport problem, including all the equations you defined. So, or here means all the equations you defined previously. If you just only want to include several of the equations you defined previously, you can list them out. For example, here we define cost. So if you don't want the other two equations, you can just put cost here. So it will only include that equation. So this is the overall framework, and you can put the solve statement. Solving the transport problem using the linear programming, minimizing Z. So this is very clear. So you must include all the key points, including solve, the problem, and the type of problem, minimizing or maximizing, and the objective function. Then after solving, you can display, and all the variables can be shown. When you write the display statement, you need to write down display, the variable you want to display, and L here means level of primal value, which means the active value, the final value, and dot LO means lower bound, dot up means upper bound, and dot N means marginal or dual value. So here, this is the result, and X is the design variable. So the level value are this column. Is this column? This is the final result, and for the objective function Z, this is the final result. So we can try to solve this easy problem using games. Here I will introduce you this problem of a simple transportation. There are two cases to supply the product, which is the cases. And these cases needed to be transported to the demand sites, which are Topeka, Chicago, and New York. So there can be different supply-demand link. So which one is the optimal one? We can solve it using optimization. So this is just a symbol of the previous graph. So there is 350 stock availability in Seattle and 600 in San Diego. For the demand, Topeka required 275, Chicago required this amount, and New York required 325. This is the distance from Seattle to Topeka and etc. So our goal is to minimize the transportation cost and subject to the satisfaction at all the markets and the supply constraints. Do you know how to solve this problem now? Can you write down the formula? Yes or no? No, okay. I can give you some hints. This is the overall problem formulation, and this table just describes what is included here, right? So these are the distances from each supply to all the demand sites, and this is the maximum capacity in each plant, and these are the demand in each market. The indices are the plants, which is these two, Seattle and San Diego. So these two are included in this category I. And the markets, which are these three, are included in this category J. So and the parameters include the transport cost per cases, the capacity, and the demand. So the transport cost is the distance times the cost per distance, right? And these are the distance, and the capacity AI in each site are these two. The demand BI are these three. So after understanding this table, we can define a variable which Xij, the number of cases to ship from the plant to the demand sites, subject to the shipment from each plant should be less than the supply capacity, and the shipment to each market should be larger than the demand, right? Yes. And Xij should be more than 0. So it is a positive variable. Then you can try it on your own. Let's open games. So when you open games, you can open a new file. Then you can write down your model formulation, write down all your codes. The codes are all included in this page. So if you have handouts,
This is also updated on the FALE code as well. You can
Yeah.
download the example. It's easier to open the webpage and see how it's written.
yeah, you can, once you have finished, I would like to tell you something more. Once you have finished coding, you can press this button. This one, run. And then it will run to get your results in 1 minute, less than 1 minute. You click display, and then you can see the results. So the optimal result is shipping 50 cases from Seattle to New York, and others shipping 300 from Seattle to Chicago. And the optimal total cost is 153 in total. You can start coding and raise your hand if you have any problem. You can try to code by yourself first, and if you come across any problem, please let me know in the following 15 minutes.
while you're practicing on this example, just add some remarks. You can continue. Just some remarks why we need to learn the GAMs, right? And some of you ask very good questions. Why we add the constraints to that. So the reason we choose those software, it's really based on our needs. GAMs is easier for large-scale optimization problem. You say it's way to optimize. To write it is you define clearly your unknown variables, x, y, and then the subscript. If you have a huge problem, you can write it in a list and then define those values. And it's not as sensitive like to space, like Python later on we study. You must add this one space. If you add extra space, it will give you error message. GAMS is okay. It's not that restricted to the formatting. So you can write in the required format and then run it to see the results. And some of the modeling is very specific to it. Let's try here. So you see, you write it as a greater than, or less than, or equal than. So those things are the ways how we write a constraint, right? It just uses this is equal or larger to, this is small or larger to, this is equal. So this is the way GAMS specify those. It's some weird thing, but it's defined by the software. And also I got some questions about how do we add constraints. So this is not about how you use software, it's really about how you model problem. So far we only introduced how to solve an unconstrained problem, but later on when we think about the constraint, is it better you formulate it with more restricted constraint, or if it's better you just use this inequality or equality? So it's all how you model your problem. Sometimes it's not, you don't want to constrain your problem too much. You can release this a bit and get some feasible solutions. So it's modeled about how you model your problem. But this is quite advanced later. It's when we introduce how to solve constrain the problem, you will learn more about this. For now, you can just get used to the software interface and solve this example for now. So once you know this structure, you can also, like you introduce, you can also try how do you find from your library, like the GAM software, or all the software, even Matlab, all the software, it produces you very good examples from its default menu. So you just use the library function and open some existing example there. You can then learn from these examples. Okay, if you have questions, you can also go to the Slido, and this is the number W022. You can ask me any question there, I will answer you online. So I did a poll to ask you how many you have used Matlab, Python, or GAMS before. So it seems everyone has used Matlab before, at least from the 20 answers that I collected, everyone has used Matlab. So this one is really about based on what you know about Matlab. At least you know how to open Matlab and then just try to use some functions, fmin search, fmin com, those functions to give you optimization. Or an easier way, now Matlab has lots of optimization toolbox. Next lecture we can also practice a lot on that. The optimization toolbox is a nice interface, you can use that. The folder of code I provided to you online, if you download it, you can find many of them are functions. Functions means it's written already, so it's like the algorithm, the way it's written. So you can call this function to use that directly. Like what Jia introduced, those functions, you can add this function by using this function. But some of the code are script, which means you can open it in your script folder and then run it one line by one line, or run it in a sequence. But only 2 or 3 students have used GAMS before, so this kind of new thing to you. It's good that you can practice to see how this example can be implemented.
Yes, and I would like to introduce you this website as well. you can continue coding. In the games website, you can check the language and environment. When you come across any problem, you can check the documents. Games is also able to exchange data with Excel or other software, so you can check in this website to learn how to do that. Because of the time limit, I'm not able to show you everything. So if you want to learn, there are a lot of information here. And games also have a lot of already developed code. So you can check the model library here, and then there are a lot of already existing problems, so you can learn how they formulate the problem in games model library. Of course, when you code, you could come across a lot of problems. So for example, in the transport problem, if I miss this semicolon, if I run, so there will be error messages. Then how to solve the problems? You can click the error. It will show you where the error is, and then there is also a description about the error. So looking for a semicolon to get started again, then you put into what is missing, then the problem will be solved. It is better to and because I'm using the Chinese I need to change it into English version, then yeah, it is also detected. Okay, continue coding. Do you have any problem? Do you have any question? Yeah.
How do you set the bounds for this problem? Because for the capacity, it's not defined. So if you want to set the bounds, how do you?
Yeah. Here is the variable. So x is the shipment of cases. It defines x as a positive variable, right? You can also change it using the lower bound of x is 0. So using this line, you can define the lower bound of variable x. Error message.
So note some like the formatting requirement. Why do you need two dots after each like name? Those things just required by the software. So it's not just some different programming laws by the software.
Yeah. So to set the bound of variable x, you can put dot low. LO means low. So it means the lower bound of variable x is 0. Any other questions?
Any questions? questions about the Matlab code earlier. I got one question about the in the data fitting problem. Why do you need add a random? So it's very nice catching. You see, I added RANDN there. So random. Why do we need a random there? Because this case it's not relevant to optimization. This case is I want to generate some noisy data to show you with this data how do you fit a model. That's why we need just on purpose add some noise to that data because random will generate random numbers to the initial. We just fit a perfect line and then add some random noise to that and get the original data set and then show you if we use optimization to minimize the fitting error, we are able to fit this line. So that's very good catch, but it's not relevant to the optimization model. It's just a Matlab operation.
Last point before I pass to Yinan. If you want to check which solver the problem is suitable for, you can click File, Options, and then Solvers. So you can find out the solvers that is suitable for your problem type. That's it. Thank you. I will pass on to Yinan to talk about Python.